Hi, thank you for joining us today. This is Nathan Nichols. I manage marketing and operations for MetaScale. We're a big data company of Sears Holdings Corporation. Today we're talking about machine learning and modern big data tools for retail analytics. Earlier this year we ran a webinar on data mining and machine learning, just providing an overview of tools. And that webinar went pretty well. We had a good response and requests for a little more information. So today we're taking a little deeper dive into machine learning and recommendation engines, specifically around retail, though the frameworks that we're talking about can certainly apply to any industry. With me today is Amit Sid, our Senior Technical Consultant, and Bharat Prasad, Lead Big Data Solution Architect. Just give a quick overview of the agenda. We'll cover a brief overview level set of what is big data, using big data analytics and machine learning, why use mahout, and then we'll be closing with a demo on recommendation systems. At any point throughout the webinar, feel free to send your questions through the chat function, and we'll be holding Q&A at the end. So with that, I'm going to pass things over to Amit.
Thanks a lot, Nathan, for that introduction, and I really appreciate everyone who has joined us for the webinar today. So for those of you guys who this may be your first time listening to a webinar, I want to give you a little brief overview of who we are as an organization. So MetaScale is a big data technology solution provider. We're known in the industry as a big data accelerator. We've got knowledge and experience in big data platforms such as Hadoop and NoSQL. We do core competencies such as professional services, managed services, and training. Where we get our foundation from is from the Sears Holding organization. MetaScale was built out of a group here at Sears who was working on a few projects and decided that one of the projects needed an open source platform to be used in order to meet the specific requirements of it. They ended up adapting Hadoop, and we've done and did about roughly 50 use cases internally and had a wide variety of success. So they built a technology group out that would be able to provide those services, that knowledge and expertise to the masses, and that's where we are at today, MetaScale as an organization. So what I want to get into first is, what is big data? For most people out there, big data has been a term that has come across, your desk, your computer. In some line, you've had some interaction with that term. The way that we define big data here is the amount of data, but not the amount of data, but by the type, speed, and storage capacity needed to compute that data. Typically for most organizations or most individuals, when they hear the term big data, they immediately assume that we are talking about size or you're talking about volume. But the way that data is today, it encompasses so many more things that are not just based on size. There's things such as, variety of data. So the type of data that is coming in. That data can be, structured, it can be unstructured, it can be semi-structured, and for retail organizations, this is some of the data that oftentimes, due to storage limitations, is often, just been kind of thrown away. There's tons of survey data that you may or may not be getting from either your call center or online surveys, and that information is valuable. That information needs to be captured. Also, when you're looking at big data, we also look at velocity. So going back to the speed that data is coming in. Is it batch? Is it periodic? Is it near real time? Is it real time? And when you're thinking about situations such as your e-commerce or your inventory management, this is critical. With the velocity or that speed that data is coming in, can you imagine if you have an e-commerce platform and it takes multiple seconds to load. That can really, have an effect on, your business. And, when in a fast-paced society, really we need to be able to have, your data come in. You need to be able to come in and be aggregated and looked at in a quick and efficient manner. So we, see what big data means, and we see, the type, the speed, and the variety of data that we are experiencing today. And it's really, in the last few years, has really changed through the invention of, mobile devices, tablets, laptops, desktops. There's been a lot of changes to the way that data is being received and the type of data that we're getting, and it has presented some challenges for organizations. So really when we're thinking about, large-scale data processing, one of the main issues that for most retailers that they're facing is that oftentimes some of their systems are legacy systems. So you're dealing with systems that normally have not had to handle the volume of data that, was just mentioned, or not even had to deal with the type of data that's just mentioned. And that can cause, multiple issues. It can cause storage issues. It can cause processing time issues. It can cause issues associated with cost. What we've seen and, within, the problems with processing, large-scale data is also, data latency, and then also an overall lack of, quality analytics, meaning that, oftentimes in traditional systems, you're not able to, compute everything. You oftentimes have to, omit certain things. You oftentimes are not able to, process data for, you may have 10 years of data and can only process 3 years based on your, current limitations. So these limitations have really been something that, in a traditional system has been a cause for, issues and oftentimes cause for concern when organizations are really thinking about and looking into adapting, big data as a, tool to be used to provide insight into the data that they're working with. So with that being said, I want to, talk a little bit about, Hadoop, because Hadoop really brings that, infinite scalability for your large-scale data storage. So when, we're talking about Hadoop, we want to talk about it as it relates to, being a stable system. So the system, when you are looking at Hadoop, it is stable. It's horizontally scalable. So when you're thinking about that large amount of data that's coming in, so whether that is your, growing customer data due to maybe rewards programs that you're doing, whether that's the growing marketing data due to the different methods that your retail organization is marketing to individuals, you really need a system that can easily be scaled out to fit not only your needs of today, but also the needs when you're looking at, 3 to 4, 5 years down the line, and a system that will still be able to handle that volume. The economics of it is something else. When you're talking about, traditional systems, when we have to add additional storage capacity, it can oftentimes not be efficient to do so. I know that the organization that we were built out of, one of the reasons for adapting Hadoop was that, our IT budget, as most organizations, was constantly saying the same. But we constantly were having to add storage space due to the amount of data that was feeding in. And for most organizations, you're going to have to show some sort of result to actually get that IT budget increase if it even does happen. So what you need is a system that is economical, that is easily scalable, and because Hadoop does sit on commodity-based hardware, that's a situation where it has been, very economical for organizations to process a lot of data quickly and efficiently using the power of parallel processing. We're also talking about the reliability. You are able to, copy your data on 3 different nodes, so the data is always copied 3 different times. If, your job fails, that job is just repeated. There's, because that data is stored in another place, it finds the data, and the job just repeats. From a storage, again, I mentioned earlier, due to, a lot of constraints with storage, a lot of organizations have had to, toss a lot of data out that they would normally, like to keep because of those limitations. But with Hadoop, typically you're going to be able to keep everything forever. So once you've made that decision that, we are as an organization going to use big data in order to find insight, and we've said that, hey, we're going to use Hadoop to combat some of the challenges in legacy organizations, what do you do at that point? So from that point, typically for most people, you are going to want to, it's not just going to be magic. It's not just, a lot of people have a misconception that once we start applying analytics that everything is going to change immediately. It's not. It starts with a process. That first part of that process is understanding. And as you can see from the picture below, there's a nice, clean, clear dashboard that's, showing you certain things about your data. So you really need to understand, what is your data telling me? What is this data telling me? And I think that goes to when you are looking at developing a strategy, is you have a team of people that are going to be exploring this data, and they're going to come to a group decision saying, hey, this is what our data is telling us. And then once you understand what the data is telling you, you want to be able to apply that. So from an apply standpoint, we want to, understand how we can make changes to better fit our organization based on what that data is telling us. So from a marketing standpoint, if you know that your data is telling you that maybe a specific region, sales are low in a certain target market, say 25 to 32, you're going to say that, hey, we're going to, in our marketing, change maybe the way that we are going about direct mail marketing to those individuals. And the reason being is because maybe it's shown from other information that you have that you're not missing another portion, that you're missing a portion of that process. And that next portion is connect. It's great to be able to, understand what you're doing and then to apply that change to that process. But if you're not actually connecting with the individuals, then you're going to completely miss the opportunities that you need. So going back to the direct mail standpoint, if you're understanding that, hey, we are having a problem with our demographic between 25 and 32, and we've made the steps to apply that data, and we're going to try to connect with them. We're going to try to connect with them in a different way this time. What we're going to do is we're going to send maybe more mobile applications. More mobile messages. Maybe we're going to hit them in more locations that we know in this area that people within that that segment are going to be, at and are going to see our messaging. So once you have connected with them, the next thing you're going to want to do is influence them. So when I say influence is for every retail organization, it's always not only getting you to buy products initially, but also getting you to come back. So ways that you're going to go about influencing them is, sending specific, coupons or messages, again, in a format that they see. So mobile saying, hey, come in today, the next 24 hours, we have, you'll receive 24, or you'll receive maybe 25% off. Or saying, if you go to our location, maybe a location that is specific to where they are living at, you'll receive an additional 20% off. So again, it's influence them in a way that you connected with. It's influence them in a way where you connected with them already, and then again through that understanding and that application process. So when we're talking about that what to do now and the understand, apply, connect, and influence, there's a lot of different analytics that go into that, and that's where we're going to get into machine learning. So machine learning is learning computations that can learn from your data. They're using representation and generalization to evaluate instances. Focus is on predictive based on non-properties training data. So one of the common misconceptions of machine learning is that machine learning is just a hybrid of, data mining or predictive analytics. Machine learning is actually a lot different. Whereas data mining focuses on, discovery of unknown properties of your data, machine learning really focuses on, developing algorithms that make predictions on that data and are ever changing, learning from the, the data that's coming in. We really want to focus when you're looking at machine learning on correlation. So things that are showing patterns or things that are showing the, odd man out. And that's really where machine learning allows you to really gain, a lot of value. And if you are looking at machine learning, for most organizations, who are thinking about implementing machine learning, if you don't have a large data science team, or if your data science team is maybe kind of green in that space, then there's a tool that you'd want to use. That tool is called mahout. Mahout is a top-level Apache project. Apache, the same group that has other projects such as Hadoop. It's easily scalable machine learning algorithms. It has pre-built libraries. There's roughly about 50 pre-built algorithms that, sit within mahout. Its primary focus is recommenders, clustering, and classification. It is built on a Java framework, so what that really allows is that, if you say you have a smaller data science team, or maybe, again, your data science team or maybe you don't have a data science team at all. A lot of organizations, again, are just kind of starting to really get into the analytics, so maybe a situation that you don't have a data science team. Then this is a great way and a great tool that allows you to easily start applying some of these really advanced techniques within your organization. So that Java framework, it really allows individuals who do have that, Java background to gain an understanding of the, APIs, and then begin making applications, within mahout, and it allows you to easily scale out, large-scale, data algorithms when you are using a tool like Hadoop, if it is a large-scale processing, a large-scale processing of data that you're doing. One thing that I do want to mention, though, is mahout is not specific to Hadoop. It can be used, on a smaller scale. But if you are really looking to, maximize the processing power that is available through Hadoop, and you're using a large amount of data that is being processed, then Hadoop is definitely going to be the way, in a cost-effective way to get that done. So let's kind of get into a little bit of the primary algorithms that are associated, with mahout. So there's three common, algorithms associated with mahout, and I really kind of look at these three as, almost like your primary colors. They're going to be the three that are going to really have, that are going to really kind of build the framework, and then from there, everything else is built out. So for most of the algorithms, as far as, clustering, just the process of grouping, similar things in such a way that, like items are grouped together. You have classification, just referring to more or less the categorization, of objects. And then you have recommenders, a subclass of information filtering systems that seek to predict ratings. Each of these algorithms do have other more advanced algorithms that sit underneath them or within their family, and there's a lot of information. Again, the Apache community is really good about adding new algorithms, making updates to the current algorithms, and also allowing users to comment and add information that allows the algorithms to always be more valid and more effective. So when we are looking at how that process works, you have mahout on the top, and then if you're using Hadoop, then you have that MapReduce process, which is going to take on those ingrained algorithms, and then you're going to begin working on your use cases. So whether those use cases are within recommendation systems, whether if they are a clustering use case or a classification use case. That's kind of how that, the steps in that process is going to typically, work. So as we're looking at, a couple of the examples of use cases, so really for most organizations who are investing in analytics and are really looking to make more finite decisions within their organization, the use cases that you are going to be developing are going to be what's really going to, drive that business value. So for e-commerce, clickstream analytics is really something great, really to gain a better understanding of user behavior. So seeing, how users, tracking the path of how users are interacting on your website, and then again, making changes based on that individual user's behavior. Again, for retailers, it's all about not the, large scale of things. It's about those finite interactions that you make along the way with each of your customers that really influence their behavior and really make their experience better. Again, if you make their customer experience better, there's a stronger likelihood that you're going to be able to win their business. Also, credit card fraud is another thing that machine learning and mahout does very well. Understanding customer transaction and then identifying potential fraudulent behavior. So it's not necessarily looking at everyone. What it's looking for in that situation is the outlier. So the people who, based on the patterns that are being seen, are not fitting in that pattern. And those are typically the people who are going to be committing those crimes, or who you may want to take a second look at when you are looking at potential fraud. Customer segmentation, so really using patterns of past customer behaviors to determine current and future customer actions, and that's something that relates similar to some things we'll talk about when we get a little bit further into recommendation systems and also collaborative filtering. Product recommendations, that's another thing that really for retail organizations is a huge part of their business. So being able to see what customers, what specific users are buying, finding other users that are similar to them, and then being able to specifically target what you're going to be sending to those additional users. And that also works the same thing, when we are going to be talking about recommendation systems. That'll really move us right into that discussion, and that's up next. So with recommendation systems, most of individuals have probably seen some sort of recommendation system, whether they know it or not. Amazon, if you have been on there, maybe you're shopping for camping equipment and you're looking at tents, you know that you will oftentimes get flashlights, you'll get waterproof matches, you'll get other things recommended to you that relate similarly to that product that you're working on. So really, recommendation systems are looking at a couple of things. They're looking at, specific users, and then they're also looking at specific items. And when we're talking about those recommendation systems, those are going to be two key areas that, really determine what that recommender, or what is going to be recommended to that particular individual. With that being said, there's two main types of, of filtering that we can look at when we're looking at recommendation systems. So one of them would be collaborative filtering. So collaborative filtering means that you look at Mr. A. You see his preferences, and then you're also looking, when you're looking at a user-based recommendation, then you're looking at the group's preference. From there, you are looking at, understanding what Mr. A likes and what groups of people similar to Mr. A likes, and then from then making a recommendation that will hopefully influence, Mr. A to, purchase that product, or to, buy another product that he may not normally look at. When we are looking at item-based filtering, it's very similar to that. It's really going to allow that individual to It's going to really target more along the lines of, looking at specific, items that have been purchased and then finding other items similar to that an individual would actually like or could actually purchase. So the main thing to think about when you're thinking about collaborative filtering, the big thing is correlation. So finding things that correlate or things that can also be outliers or outside the norm that allows individuals to make decisions that they normally would not make. So as we move forward, the next type of filtering I do want to talk about is content-based filtering. It looks at items in the user's preference in order and provides a recommendation. So it allows a highly precise recommendation. So it looks at your rating of particular, movies, of particular restaurants, and then also it looks at the user profile of that individual, and then it's going to take into account the features of other similar, movies or other similar restaurants, and then it's going to build a content profile that ranks that content in a manner in order to be able to distribute that or recommend that, to the user based on what he or she has previously looked at or done. So what we're going to get into now, as we're kind of getting toward the end of our webinar, is we're going to look at some reference architecture for a recommendation system that was built by the MetaScale team here. It's built completely out of open source tools, and again, with the wide implementation of open source, and the huge community that supports open source, I really would, suggest, and I'm kind of biased, to using open source tools as much as you can. Really, the only cost that typically is to the user is that development cost, but it does allow a lot of flexibility, and you can really tailor it and make it your own. With that being said, I want to turn things over to Bharat, and Bharat will walk you through this reference architecture and also take you through a demo of a custom-built recommender that MetaScale did.
Thanks, Omid. I think Omid already completed he's covered most of parts. What is our technology, or what is the technical terms we have used over here, what the algorithm we are used over here. So, but I will go in more detail during the demo page, but I would like to say something over here. What the algorithm we use. We use the collaborating filtering over here, and the model, that we have two models for the collaborating filter. One is the memory based model, and the another one is the model-based model. So in the memory-based model, generally we are using the what type of rating the user has bought that. So user has given some rating, whether it is between 1 to 5. So based on that, we are collecting those models, and then we are processing those models and creating a vector model top of that. So we should have a set of users, we should have a set of items, and then we are correlating based on the transaction data, what they bought, what preference they have given. So those information once we collected and put into the model, and then we apply the mahout algorithms top of that model, and then we will get some result set. That result set is nothing but that is your recommendation. So that is you can say the memory-based model and as well as the model-based model. So I will give in more detail about the technical terms when I will land into our demo page. Just give me a few seconds. Okay, so I think you guys can see our demo page. So this, and also I would like to say the model, what approach and what process we are using here. Also, we are using the user-based model and the item-based model. And also the second approach we have used, what a person, if person have a history, person have a behavior, purchase history, behavior, so then we can recommend that. But suppose if person doesn't have any history, behavior, then what system will think about? How we can recommend the system? So those things we have kept in our mind, and then we design this system. So first you can see if system have some user and history behavior, then what system will recommend that? Let's go. I have a one user ID. Let's put 121. I have one, and then password. So now you can see the system is saying you purchase trains, vintage car, classic cars, truck, and buses, where these are the item you have selected. So now the right side you can say our system is recommending these things. So how the system behave that? How system is recommending these only? We have a tons of items. Why the system is recommending this items only? So based on, just I explained, based on the user behavior, based on the ranking, so based on the memory based model, if either we can choose the memory model or the model or model based model. So generally in our model based model, we have to give into the input as a item as the input, user as the input, and then we have to also provide the preference. Once we will create this model and then give to this model to the system, and then our system will apply on that model, and then we will provide some tips for the recommendations. So this is based on the history behavior, but suppose, and also I can see here, now you have item based recommender, and also if I switch to user based, so now you can say some little bit change. So this is not recommending what you like, also this one is recommending what the user, other groups, just Omid explained that, what other user like that. So now you can see the user bought trains, vintage car, or classic car, but our system is also showing the trucks and buses. Why this is so? Because that system is thinking about the other groups, also given some preferences, some choices about that. Basically it's if you are going to the Boolean model, it means they purchase that and they have given some rank. So based on that, we are means the system is considering many permutation combination. It's not just based on your behavior, it's based on other groups behavior as well, other groups preference as well. There are so many things we need to consider for the when we are recommending, or which system is recommending to any user for that. So now you can see we also recommend item based, also we can see the user based. So once we are saying the item based, so always we are thinking about the preferences. When we are saying the item based, we are thinking about the other groups preferences as well. So now let's, so this is the one of the use case where if user have some history, some user purchase behavior, but the another use case, if suppose we do not have any history or behavior for any particular user, then we need to sign up that one. So let's see, I am just signing myself. And then see what will happen. Okay, so now you can see we have a list of items. So for here I'm using the training data, but a very small data set for the demo purpose. So you can see we have trains, vintage car, planes, ships, motorcycle, and classic cars and trucks. Let's start purchasing, or let's start our behavior, means what you are going to choose that. So I choose trains, this, planes, I like planes, so I just choose this, and then I like motorcycle, so let's choose BMW, this, and then submit that. So once, right now what we are doing, the process is, the user is already there, now we are purchasing some items. So once this whole model is created, then we are going to apply the algorithm, that is the CF algorithm, and the method, the similarity co-occurrence method, which is Omid already explained that. So now we are going to apply that algorithm as well as that method. Once you applied that and click on submit, then system will. So now you can see there are two things you can see over here. We bought trains, planes, and motorcycle, but here also our system is recommending for classic cars. So this is user-based, means the group of people also bought the classic cars, but they are likely most. That's why the system is considering those points and they are recommending to you. But Also, you can see you bought motorcycle 19, the similar item as well. Means it's a similar item as well as the based on the group choice as well. So you like 1997 BMW F650, but our system is recommending 1960 BSC Gold Star. On what basis? Because the other groups, other user already given the preference, other user given the rate of that system. That's why the system is capturing those information and sending to you as a recommendation. So this is all about our model base and the memory base and their different use cases, basically based on approach user point of view as well as the item point of view.
All right, excellent. Thanks, Bharat. We do have a couple questions coming in, and again, I invite you to send all your questions through the chat feature, and we have about 5 minutes here, so we'll get through as many as we can. The first question here, I think, would be a good one for you, Bharat. You're showing that the recommender you used is MongoDB. Why did you choose that over Cassandra or HBase?
Yeah, we have done a lot of exercise on that because there are many NoSQLs in market, but we got MongoDB and HBase is a good candidate for that. But when we are going more in detail, when we are comparing the MongoDB and HBase, then we got the MongoDB is very easy to use. You can implement the multiple indexes on same collections, and also you can see that random small reads and write, and also the sorting point of view, the MongoDB is offering the auto sorting, and the most important, the reading performance. The reading performance is very good as compared to the HBase. That's why we chosen the MongoDB for this whole exercise.
Okay, excellent. This question I think would be good for Mid. You were talking about use cases earlier. How do you choose the use case to get started with?
That's a very good question, Nathan, because typically what oftentimes happens when organizations decide to adapt big data is the big data strategy that they have, may not be the, best based on the data that they're working with. And the big data strategy that you initially choose is going to be very important to the success of the overall project as a whole. So normally what I suggest is pick a project that deals with data that is not mission critical. So not something, typically in finance is something that you would want to start off with. I typically say that, for a lot of retail organizations, maybe start with your marketing department, maybe start with some things surrounding inventory management on a small scale. And that's usually some, good areas to typically target. Even call center data is great. There's a lot of things that you can do and that you can tweak early on, whether it's, your, volume of data that you're bringing in, whether it's the, algorithms that you are working with, or, the way that you're going to make that change when you're looking at, that connection with the customer. Those are really going to be your, things that you can see an early ROI on, because there's a lot of flexibility specific with that data and a lot of different things that you can do and, get some results and get some quick hit results in there.
Okay, interesting. You mentioned earlier about mahout's ability to process images. How does machine learning processes work with speech recognition?
Okay, so there's a couple things that machine learning does with speech recognition and imagery. From an imagery standpoint, if you've ever used Facebook and you've uploaded a photo and you were curious on why you were able to already automatically be tagged when you're looking at that photo, what machine learning does is, as it's constantly saying that data or those facial points, because it's going to take specific points of every individual's face, and then it's going to match it to data that's coming in that matches that individual's specific facial points. And then from there, that's how it knows to tag, say, Mike Smith, in that photo immediately. So from a voice recognition standpoint, machine learning is used in things like Siri. So if you have an iPhone and you've ever used the Siri, the voice dial recognition system in there, it gains an understanding of your voice and the diction within that, or excuse me, gains an understanding of the diction within your voice, relates that to, you know, syllables and sounds, relates that to, you know, words that you're saying, and then pieces everything together in order to give you a particular response based on what you've done.
Okay. We've got a couple more questions, but I think we have time for one more. Maybe I'll let you guys decide which one would be the best to answer this, but is statistical modeling equivalent to mahout?
I can take that one. No. What statistical modeling does is it only identifies relationships between variables by using, you know, basic mathematics. What mahout does, or excuse me, what machine learning uses, is it uses statistical modeling to train the system and generate models from there, models and functions from there.
Okay. Great stuff, guys. Thanks, Amit, and thanks, Bharat, and thanks, everyone, for joining. Just a recap, we will be posting the video of this webinar on our website, metascale.com. And as referenced earlier, we do have another webinar from earlier this year on data mining and machine learning that you might want to check out, as well as a variety of other webinars on various topics. MetaScale, just to give a quick news announcement, we are exhibiting at Strata, New York this year. We're at booth number 439. So if you're going to be out that way in October, I encourage you to stop by. We'll be showing some other demonstrations, both at our booth and our partner booth with Blue Data. Again, I thank you all for joining us. If you have any questions, feel free to call us. Our phone number is 1-800-234-8769. And, of course, you can reach us at contact@metascale.com. Again, thank you all for joining us, and have a great day. Thanks, Amit, and thanks, Bharat.
Thank you.